Welcome back to NewsX World. I'm Thomas Porteous and you're watching FutureX, where we bring you the latest innovations and trends shaping the future of our world. Today we're diving deep into the cosmos, exploring the frontiers of space and the mysteries of our universe. From gravitational waves to the cosmic microwave background, India is making its mark in cutting-edge astronomy research. With the Raman Research Institute leading the charge, scientists like Dr. Tarun Sauradeep are analysing data from global detectors and unravelling the secrets of the early universe. To discuss India's role in cosmic discoveries and gravitational wave astronomy, we're joined by Dr. Tarun Sauradeep, the director of the Raman Research Institute. Dr. Sauradeep has been at the forefront of cosmology research, from analysing LIGO data to studying the cosmic microwave background, and he's here to share his insights on the future of space exploration. Thank you very much for joining us, sir. It's a pleasure to have you here on the broadcast. My first question to you is as the director of the Raman Research Institute, could you give us an overview of your journey in cosmology and how India's contributions to gravitational wave astronomy have evolved?
So it's been an amazing journey for me as well as the country in cosmology, and gravitational waves is a part of understanding cosmology as far as my experience has been. So I started as a student when the first microwave background fluctuations were detected in '92. At that time, in the '90s, I was the only student who graduated out of India. At this time, we have a very strong group of people in cosmology who are ready to take on more ambitious projects, in fact, even gravitational waves from the beginning of the universe. And in between, I was kind of very involved in pushing gravitational wave astronomy with the possibility that a LIGO detector could be set up in India. And I'm happy that that proposal, which was put together with bringing a lot of colleagues from various subjects, including the gravity wave community here, is approved and is fully funded, and soon the major construction is going to start. So I expect a groundbreaking ceremony very soon. So these are, sort of very gratifying, because these are the areas, I think that can define our place in the world, because these are efforts at the frontier of science. They also require frontier of technology. So a country being able to take lead in this, it does showcase an ability which is important.
Gravitational waves were a groundbreaking discovery confirmed in 2015. How has this opened new windows into understanding the universe, and what role has your team at RRI played in analysing data from detectors like LIGO?
Yes, the gravitational waves, as you know, that it was a century in waiting to discover gravitational waves. And what has been really interesting is, in India, a group of us could identify that this was a subject that was about to emerge as an observational field 10 years in advance. And this, true to our expectations, has opened completely new windows. I mean, we are able to look at the universe in a very different way, because gravitational waves come from the heart of astrophysical phenomena. Light comes from a shroud of gas around every phenomena. So that itself, is almost like, the difference between X-rays and other probes we have. So it can get to the depth of the phenomena. And the other thing is this really also is a big boon for astronomy because this has affected, or kind of contributed to our understanding of black hole populations. There are a lot of new, um, you know, uh, things that we are finding where theorists are scratching their head to figure out how could they happen. We are finding that black holes exist at masses which we didn't expect astrophysically, and that opens up the role for the primordial universe to have played a role, which again, kind of dovetails into our interest in what was the beginning of the universe.
And in the field of cosmic microwave background experiments, what are some of the key mysteries about the early universe that your research is helping to unravel? And why is this important for the global scientific community?
So cosmic microwave background comes to us from a very early stage of the universe. So just the discovery itself and then the fluctuation in information, gleaning that has really made us go back to a time when the universe was a 1 day old baby relative to a 100-year-old universe now, right? So that's the kind of contrast. But we want to understand the first year of the baby, and we are still pursuing other signals that are buried in the cosmic microwave background, such as gravitational waves from the beginning of the universe. And this is a global quest. And I strongly believe that as we succeed in, kind of addressing such global quests, so we have to conquer some technology, and we think we have that in hand. We need to now find a way to send it to space in a space mission. And this is something that is a major, you know, a quest in the field. And you can even see when the Nobel Prize for gravitational waves was given, Ray Weiss and Kip Thorne both mentioned that this was what they expect to be the next milestone discovery in science.
With the rise of international collaborations in astronomy, how is India positioning itself as a leader in gravitational wave research?
So, gravitational wave research has been in India since the 90s. In fact, even earlier, Professor Vishweshwara had done some work in the 70s. That's very important now. In fact, we're having a conference on that. I think this is very important that we are, and the government has supported us in setting up a entire apparatus called LIGO India. And as that comes up, this is going to be like equivalent of any country that hosts a major facility in the country, and that is going to position India as a major player in this field because we will be making observations from where science is done. We will also be developing technology that allows such observations. So, and this will also showcase a successful, construction and commissioning of LIGO India. Would showcase the capability of the Indian industry. I think Indian industries which will build this will really have a huge star to kind of tom about to the rest of the world.
Now, looking ahead, what potential discoveries in gravitational wave astronomy, such as black hole mergers or neutron star collisions, excite you the most, and how might they challenge our current understanding of physics?
So as I told you, the population of black holes we are uh, observing now already challenges our understanding of physics as applied to astrophysics. We could be missing details there, or else these black holes could be of an origin which is not astrophysical, but they were generated in the early universe. And we know of processes which can do that. So that is a major uh, possibility that excites me as a cosmologist. As neutron stars collisions, of course, are a big mine of information for astrophysics, and a single neutron star merger that had been successfully followed up in electromagnetic telescopes involved 70 observatories across the world and was followed up for more than a year. So you can imagine the excitement of measuring more of them, and LIGO India will allow that. So this has at this point, kind of refined our understanding. There hasn't been something in the neutron star space which has surprised us, but there are interesting things. Again, in the cosmology case, we can use neutron star mergers and the electromagnetic follow-up to get a very independent handle on the measurement of our expansion rate. And at this point, there is a kind of a crisis in cosmology that two sets of observations are not agreeing with each other. And this is something that can really be looked upon as some way to arbitrate between the two things. And the difference is not much, but the measurements are so precise that the difference is very significant.
Cosmology often intersects with big questions about the origins of the universe. Based on your experience, what do you see as the biggest challenges in reconciling generational relativity with quantum mechanics through gravitational wave studies?
Yeah, so this is a very nice question. So you might wonder, why do we want to measure the primordial gravitational waves from the universe? We have already measured gravitational waves. These are of astrophysical origin, and these waves are necessarily classical. The waves that we are looking at from the beginning of the universe, in our understanding, current understanding, would be of quantum mechanical origin. They would be produced quantum mechanically. That would lend support to the fact that almost everything that we see in the universe as objects had a quantum origin. So it is kind of an amazing, uh, you know, some sort of confirmation that quantum mechanics, as applied to general relativity, can give you something, some predictions that can be verified. That would be a step. The very discovery of gravitational waves is a major step towards quantum physics and quantum gravity, in the sense that quantization of gravity is the big challenge, and that's where we expect either quantum mechanics or general relativity to sort of give way to a more broader theory. And the gravitational wave studies, both the ones from the beginning of the universe, uh, would kind of, and the astrophysical ones, will be a major step, because in the astrophysical case, we are also looking at, the black holes, which are very strong gravitational objects, and the kind of signals that come out when two black holes merge to form another one leave certain traces which are very unique to general relativity. And if there are deviations to general relativity, they are likely to show up there. And there's a huge effort in the community. So testing general relativity to extraordinary levels is already happening with gravitational wave studies. And that will tell us if there is some direction in which either general relativity or quantum mechanics needs to be modified to accommodate quantum gravity.
For our viewers around the world, how do advancements in your field, like those from RRI, impact everyday technology or our broader perspective on humanity's place in the cosmos?
So this goes back to my mention of a cycle of quests and conquests. So quests to me are scientific quests which deserve an answer, and these could be just driven by curiosity, or they could be driven by a major crisis like climate is a quest. I mean, how to understand the climate and mitigate issues. but similarly, how to understand the fundamental forces in nature or the fundamental behavior of light and matter in the quantum realm are important. So RRI does work on uh, these frontier areas from cosmic scales, then astrophysics, and then down to scales where we are looking at the quantum of matter, right? So we have labs which will be looking at phenomena happening at attoseconds. We have labs which are, looking at quantum mechanics in action, discovering interesting phenomena in quantum mechanics, and verifying that quantum mechanics till now is as strange as it seems to be. And it is really something that is unprecedented. And these are areas of research that are happening that will enable people to also use quantum science for the benefit of the society. We are already using it to improve the sensibility of LIGO detectors. So LIGO laboratories are the largest quantum devices. It's a 4 kilometer by 4 kilometer interferometer with 40 kilogram mirrors. But that the quantum mechanics of that is important to improving the sensitivity. But once we tame that, it should not be surprising if we start using quantum mechanics for day to day, not day to day, but important things like national security, which is to do with quantum communication, quantum computing, quantum sensing, and these are areas in which RRI is one of the leaders.
Thank you very much, Dr. Tarun Sauradeep, for sharing your insights and vision for India's contributions to cosmology and gravitational wave research. With that, it's a wrap on this episode of FutureX. For more updates on the latest innovative technologies and space discoveries, stay tuned on NewsX World.